Hi, my name's Hazem Gaber. I'm a master electrician, RCDD, and engineer. And today we're going to learn residential electrical systems and how to wire up a house. We're not actually going to wire up a house, but we're going to learn everything you need to make a house legal so that you pass your inspection under the National Electric Code of the United States or Canadian Electrical Code. So the two codes are very similar. The U.S. code is a bit more strict now. Now, first thing is when you get your electrical panel, you want to keep at least a 3 foot working distance from the panel. So from the panel door fully closed, we want at least 3 feet in the horizontal direction. In Canada, it's 1 meter, and then we want to keep at least 30 inches left to right from the center of the panel. If the panel is wider than 30 inches, then we want the width of the panel. So this should be able to keep the door open at 90 degrees. Now, the top breaker on the panel should be no more than 6.5 feet from the ground. That lets almost anybody turn off all the breakers. Now, there's a whole bunch of different types of residential panels, and whichever one you get, ideally you want to get a 200 amp panel, and the reason is most electrical services to houses now are 100 amps, but the cost between a 100 amp panel and a 200 amp panel is like $100 or $200. Now, down the road, if you decide to add an electric car charger, and in 10 years most houses will have one probably, electric car charger uses, let's say, 48 amps, which is half of your panel. So you're probably going to get a need for a service upgrade to either 125 amps or 200 amps. And the cost of changing out your panel is $5 or $6 or $8,000, depending on where you are and whether you hire a guy, professional electrician, or some guy from Kijiji or Facebook Marketplace. But it's going to be expensive. It's way cheaper to just put in a 200 amp panel now and then having to change the feeders, if that, or the main breaker as required later. So definitely go with a 200 amp panel, and definitely get a big panel so that you've got, at least 42 spaces for breakers, so you can add more circuits later. It's always easier to add more circuits to a panel than to say, oh, I'm at capacity and I need to change this thing out. Now, all receptacles in a house have to be the tamper resistant type. So when you say tamper resistant, they've got the TR on them typically, and it might be on the plastic or it might be in the metal part. And the way the tamper resistant receptacle works is it's got a plastic insert so that a little child can't stick a fork in there, because kids are curious and they will try to push stuff into there. And so it's interlocked with the ground prong, so if you don't trigger the ground prong first, this plastic part won't open. So just make sure of that. And this one's CSA approved, so you want to make sure your equipment's approved, either say UL listed for the United States or ULC for Canada, CSA as well. Now, kitchen is where we're going to start. Now, the kitchen has probably the most circuits out of any house, and we want to have, first of all, a separate lighting circuit for our kitchen. So the lights for the kitchen must be on their own circuit. They can't share with the lighting in any other part of the house. And then we're going to have a whole bunch of circuits here for the fridge. Now, this family is rich, so they probably don't eat any microwaved food, but we're going to need some circuits for the hidden fridge and the hidden microwave and the hidden dishwasher. And here's the deal. So the fridge must have its own receptacle and its own circuit, and that goes behind the fridge. Now, in the United States, the receptacle must be GFCI, so ground fault, and also AFCI, arc fault protected. In Canada, it doesn't need any protection because they say, well, it's behind the fridge, so nobody's gonna mess with it. It's not gonna get wet or cause an arc fault. And it's gotta be at least 20 amps. Well, 20 amps gives you plenty for the biggest fridge. Now, you also need a separate circuit and receptacle for your microwave. Again, 20 amps. It must be. Now, I'm just gonna skip this and let you know. In the United States, every single receptacle in your kitchen now, under the National Electric Code, must be GFCI and AFCI rated. In Canada, it's a little up and down. There's certain receptacles that are GFCI and certain receptacles that are AFCI. The US has gotten very strict though. Now, the funny thing is, microwave is the only place where you can have a receptacle in a cupboard. So generally you can't have a receptacle in a cupboard because of a fire hazard if you forget about it, but the microwave is allowed because it's intended for the microwave. And then we need technically there's no rule that says you have to have a receptacle and a separate circuit for a dishwasher, but you generally do because there's a rule that anything over 1500 watts needs a receptacle, so that's 12 amps, and most dishwashers draw more than 12 amps, so you definitely need a receptacle for your dishwasher. It's got to be GFCI and AFCI rated. Now, you're going to find on your countertop in the United States, all of your countertop receptacles must be GFCI and AFCI rated. Doesn't matter where they are, because as I said, your whole kitchen has to be GFCI and AFCI rated. Now, you can put receptacles anywhere you want, but you have to have a receptacle within 2 feet of your sink on either side. And you cannot have a receptacle directly in front of the sink or behind the sink. And then if you need to have receptacles all along your countertop within 4 feet. So there shouldn't be more than 4 feet from a receptacle anywhere along the countertop, excluding the sink. Now, in Canada, the receptacles have to be much closer, so they have to be within 900 millimeters of each other, or 3 feet. And any receptacle within 1.5 meters of the sink has to have the GFCI rating, but anything past that does not. So there was an argument over whether the stove needed to have a GFCI rating, and in Canada the answer is no, but in the US the answer is yes if it's within 6 feet. But now it doesn't matter. The stove has to be GFCI even though it's a massive load. So the other rule is, in both Canada and the US, we have to have at least 2 separate circuits for the kitchen countertop receptacles, and no more than 2 receptacles per circuit. So if you look here, we could have 1 circuit for this receptacle and 1 circuit for these 2 receptacles. So I need a minimum of 2 receptacles, but probably more. And if I got 5 receptacles, that means I need 3 circuits. If I've got 7 receptacles, that means I need 4 circuits. You know, does that make sense? Hopefully, well, you guys can't talk back, so now, if you've got an island, then you need a receptacle for your island, and there's certain rules depending on the size of the island. Now, there's receptacles can be installed sideways, but if they are, then the neutral, which is the bigger hole, has to be facing up, and that's designed so that if something falls down into the receptacle when something's plugged in, it doesn't start a fire. And you must be a maximum of 1 foot from the top of the counter. Now, if you've got a sink in Canada, then this has to be GFCI, like I said, and in the United States, it always has to be GFCI or AFCI. So, keeping that in mind, it's the first 9 square feet of island or peninsula needs a receptacle, and then if you're more than 9 square feet, then you need another receptacle for every additional 18 square feet. So this is a bigger island, so then we have to have a second receptacle. So the first receptacle will be within the first 3 feet, and the next receptacle will be within the next 5 feet. And then if this thing was even longer, then you need a third receptacle. And you got 3 options. So if your island has like what's called an overhang, then you can put the receptacle inside the millwork, or what's more likely and much more common and being mandated is what's called the pop-up receptacle, or in some cases they make an exception, and if you don't have to put the receptacle, but you do have to rough in for it so that it could be added later. Now, like I said, you need a receptacle for your oven. So the oven receptacle is a 2-pole 50 amp receptacle. So it's got ground, hot, and neutral. And you need a minimum of a 40 amp breaker, but you can do 50. You just gotta make sure whatever rating of breaker you put, you match the wiring ampacity so that you don't melt the wiring before the breaker trips. Now, in the United States, this has to be a GFCI. In Canada, it does not, but it does have a special rule, which is the ground must face either the left or the right. You can't have the ground facing the bottom or the top. The ground is a U-shaped hole. Now, if you've got a garbage disposal, that's got to be a separate 15 amp circuit, and it's got to be, it can be on a switch, and it's got to be GFCI because it's near the water. Some people will tell you no, but it's a good practice to do it. Now, you also need a separate circuit for your dining room, and it's got to be at least 20 amps. This lets you add appliances to your dining room. And then you need a 20 amp circuit for your laundry room, and it's got to be a GFCI, and the lighting for your laundry room has to be separate from this circuit. So the 20 amps is just like for your washing machine. Now, if you've got a big laundry room, it's a good practice to put one 20 amp for your washing machine, and then one 20 amp for other devices, so other receptacles within the room, and even you can put the lighting on there too if you wanted to. But you need a minimum of 120 amp just for appliances. And then, so that's for the washer. And then the dryer requires its own receptacle, and that's a 30 amp minimum. So that's this is a NEMA 1450, but we can put a 30 amp breaker for this receptacle for our dryer, which is okay. And it's got its own shape. It's different from the oven, as you notice. So make sure you match the correct breaker and wiring. And then if we've got a utility room, the utility room needs its own circuit, and the furnace needs its own circuit. And then if you've got a hot water tank, that needs its own circuit. And some people are going with inline tankless systems, and the tankless systems need their own circuit, and it could be very big. So you want to match the ampacity of the tankless circuit to whatever system you're getting. And I've seen in some houses, for example, they have a gas-fired hot water system, but they still rough in a wiring for a potential tankless system later, just in case, because you don't know, and it's better to just have it and plug it in when you need it. Doesn't really cost that much to put it in. although gas is better, a lot of times, hey, you're not gonna have capacity in your panel these days to put all these things, the electric tankless and then the car charger and then the air conditioner. It can add up pretty quickly. And you need a separate circuit for your central vacuum. And then if you've got an unfinished basement, some houses don't have basements, but if you have a basement, then you need at least one circuit for the basement. And then you need one 20 amp circuit for your electrical panel. This is in case you're working on the panel and you need to plug in some tools. Then you've got a circuit here. And then you need one circuit that's got to be GFCI, AFCI rated for your sump pump. Now in Canada it does not need a rating, but in the United States it does. And it's got to be a single pole, a single receptacle, so that you can't plug anything else into it. So see, just one plug, that's it. Now, your garage, so some people have a sub panel in their garage, which is good, and then they can take all the garage circuits off the sub panel, and some people don't. Doesn't matter. Now, in the US, a garage must be GFCI rated and 20 amp minimum. You need a light switch. You can put receptacles, garage door opener, and lighting on the same circuit, and you want to have a receptacle for your garage door opener within 1 meter or 3 feet of your garage door opener. And in the US, you need an additional receptacle for each car space. So if you've got space for 2 cars, then you need 2 wall receptacles. It's good practice to have. And then you need one circuit for the outdoors, and it's got to be weatherproof, or in a weatherproof box, and all receptacles must be GFCI rated. And if you've got a balcony, then you need receptacles on the balcony, and they must tie in to the outdoor circuit, or they can be on their own circuit, doesn't matter. But all of the you can't put outdoor circuits and indoor. You can't put outdoor receptacles and indoor receptacles on the same circuit. That's the bottom line. Now, in the washroom, you must have one 20 amp receptacle next to the sink. If you've got 2 sinks, they can share a receptacle in the center, or you could put separate ones, doesn't matter. But it's got to be within 3 feet or 1 meter in Canada of the sink, and it has to be at least 3 feet or 1 meter away from the shower, where practical. So sometimes it's not possible, and if it's not possible, then it's not possible. And it's got to be GFCI rated. Now, the other thing is washroom circuits must be separate from any other circuit. And if you've got a heater in your washroom, then the heater has its own circuit and also GFCI rated. Now, people make this mistake. So a lot of times we will daisy chain all of the washroom receptacles. So they will all be on the same circuit. So my panel's here, and I can daisy chain. So my first washroom receptacle will be a GFCI receptacle, and it'll protect all the downstream ones. So the downstream receptacles won't be GFCI, but they will have the same protection. Now some people will argue that the downstream ones cannot ever be GFCI because that'll create a conflict, and like they keep tripping or they won't work. So it's best to do it this way, where the first one is a GFCI and then the downstream ones are not. Some inspectors will fail you if the downstream ones are GFCIs. Now, when you got stairs, you want to put a 3-way switch at the top and bottom of the stairs to control your lighting. And then, of course, you've got different circuits for lighting. So for the rest of the house, um, you can put the lighting and receptacles on whatever circuits make sense depending on how much space you have. So you might put all the lighting on one or two circuits. You might put outdoor lighting on one circuit and main floor lighting on one circuit and basement or second floor lighting on one circuit. You might also do the same thing with receptacles. You can put up to 15 receptacles on one circuit, although you might not want to, depending on how big the house is and how much use you think each receptacle is going to have. So you might put, if you've got 42 spaces on your panel, you might think about spreading the stuff out, but you don't have to. It all depends what you think is going to happen. Now, but having said that, you have to have receptacles everywhere. So anywhere that's a bedroom or a living room or a family room or an office needs to have a receptacle on any wall that is wider than 2 feet, and you need to have a receptacle within 6 feet of the door. And then if we go horizontally along the wall, then the receptacles must be at least no more than 12 feet apart. So every 12 feet I should have a receptacle, and 6 feet from any door. But I don't. This rule doesn't apply inside a closet or a storage room or like a laundry room, that kind of thing. But I need a receptacle in any hallway longer than 10 feet. And I need a light switch next to every door. Now, in Canada, the rule is a bit different. I need to be able, so in a hallway, I need to be able to reach the receptacle within 4.5 meters. So if my vacuum cleaner is here, for example, I need to be able to get to a receptacle. So any point in the hallway should be no more than 4.5 meters from a receptacle, and I should not have to go through a door. So if I have in case I'm vacuuming and somebody's sleeping, I shouldn't have to go into the bedroom to plug in the vacuum cleaner to vacuum the hallway. Now, the other thing is, in Canada, we've got almost the same rule for spacing receptacles, except it's required for any wall that's 900 millimeters or longer, and receptacles must be within 1.8 meters of each other, but there's no rule about having one 6 feet from the door. Now, any type of heating, electric heating, has to have its own circuit, because heaters draw a lot of power. And then air conditioners, typically your air conditioner requires a 30 amp 2-pole breaker. So some houses come with air conditioners, but some of them they can get installed later or roughed in later. And then doorbells. So doorbells don't use a lot of power, and they take power off of a transformer, so they send 120 volt into the transformer and we get 16 volts out. So typically they'll plug a doorbell transformer into a receptacle somewhere, or a junction box, maybe in your utility room, maybe in your attic, nobody really knows. But doorbell doesn't really need its own circuit. And then the same goes for an alarm system. Typically your alarm system has a transformer just like your doorbell almost, but say 24 volts. Or it may be just a transformer that plugs into a receptacle. So the alarm system typically doesn't need any special wiring, or the alarm company takes care of it. Smoke detectors will take one circuit, or they may be battery powered depending on your setup. But if you do have a circuit, you can put I think 15 smoke detectors on the same circuit. And then you've got exhaust fans for your washrooms. So exhaust fans will have their own circuit, and you can tie all your exhaust fans into one circuit if the capacity is there. Sometimes you might interlock the exhaust fan with the lighting as well. Now, I mentioned this earlier, but what has been mandated is the AFCI breakers. So you want to have so an AFCI breaker prevents fires that are caused by arc flashes, and you want to get one that says combination type, because a combination type breaker protects against arc flashes on series and parallel circuits. They're more expensive than regular breakers. So in Canada these are like $90, and in the US they're much cheaper, but they're still way more expensive than a standard breaker. And now Canada and the US require them. So now check it out. So if we look at a typical house, so I'm gonna say this, so pretty much everywhere requires an AFCI breaker in the United States now. Any circuit that feeds receptacles or lighting in any living area, so dining room, master bedroom, kitchen, laundry, requires it. The only place that doesn't need it is the outdoors, the bathrooms, and the garage. Those just need GFCI breakers, and then everybody else needs AFCI breakers. And remember, the kitchen and the laundry room need AFCI and GFCI breakers. So, and the basement doesn't need an AFCI if it's not finished, but if it is finished, then you're gonna have to swap them out. And notice also in crawl spaces we need AFCI. Now in Canada the rules are much less strict. So if we look at the same setup here, we don't need a GFCI in the garage, and we don't need a GFCI in the laundry room, and we don't need GFCIs for a lot of the breakers, for a lot of the circuits in the kitchen, like the dishwasher, for example, the fridge, and a lot of the receptacles that are further down away from the sink don't need it. The oven doesn't need it. We also don't need any AFCIs in the kitchen except for the microwave. We don't need any AFCIs for lighting circuits in Canada. So only receptacles in Canada require AFCIs. Now the other rule is you can't use an AFCI receptacle. It has to be an AFCI breaker that protects the whole circuit, because the receptacle only protects us at the first receptacle and then further down. It doesn't protect us between the panel and the first receptacle. So in Canada you're allowed to put a AFCI receptacle on the first receptacle if the wiring between the panel and the first receptacle is metal. So it can be either armored cable or tech cable or an EMT conduit, because then there's no arc flash risk there. But everywhere else it's gotta be a breaker, and it's gotta be the combination type. So if you've got any questions, please post a comment. Thank you.